Hello, everybody. So you guys have already done ionic bonding, and today what we're going to work on is covalent bonding. Remember, ionic bonding is when two different elements they transfer electrons, and that makes them electrically charged, and so those opposite charges will attract to one another, and that's actually how they kind of come together. But those are actually easily broken. A lot of times you just throw them in water and they break apart. That's called dissociation. So we're going to talk about something that's a little bit stronger, a little bit longer lasting, which is covalent bonding. Before we do that, I just don't, this hat thing, I know I always wear a hat, but I'm not feeling it today. Let's try this. Is this better? It doesn't feel better. Whatever, my hair's done. I'm just gonna wing it today. No hat. We don't need a hat today. So, covalent bonding, what we need to start out with is a definition. Covalent bonding, co means together, and valent probably sounds like that word valence electron. With a covalent bond, what we do is we end up sharing our valence electrons together. So we get into these situations sometimes where things don't have enough electrons really to be stable. So let's look at the case of water real quick. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. And you guys probably know the chemical formula for water, H2O. We're going to put an H over here and an H over here. Both of those guys have 1 valence electron. With ionic bonding, remember it's a transfer of electrons, so here's what could happen. We could have one of these electrons that I just erased. There were 2 I erased. One of them could go over here. Hydrogen's happy now because remember it can only hold 2. This hydrogen gets the other one. It's happy. So this becomes a plus. This becomes a plus. And this thing becomes a 2 negative. But there's a problem. If you look at this, oxygen is not stable. It is not happy. Remember, oxygen would need 8 valence electrons for it to be happy. Right now it only has 1, 2, 3, 4. So ionic bonding is not going to be able to work for us in all cases. So let's go back a little bit. What we can have sometimes is we can share some of our valence electrons within different elements. So hydrogen needs 1 more, okay? What we're going to do here is we're going to draw a big cloud, okay? So now look, hydrogen is now sharing an electron with oxygen. One of its electrons, and then oxygen also is sharing one of those electrons. Now in real life, and you guys are going to do a simulation later from PBS, this one doesn't just like stick by this element, and this electron doesn't just stick by this element. So what's going to go on is these things are going to be able to move kind of fluidly within this cloud, so to speak. But right now, if you take a look, this cloud has given oxygen 1 more. So now oxygen is at 7, which is happier. It's not quite stable yet. But look, hydrogen is completely stable. So what we can do again, though, is if we go back over to this other hydrogen, and now we have hydrogen has 2 over here. Oxygen still had this 1, but now it got another 1. So let's count all the ones that are part of oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is stable. Hydrogen over here has 1, 2. This hydrogen over here has 1, 2. This is the covalent structure for hydrogen. I'm going to clean it up just a little bit just to kind of help you guys visualize it. Okay. Whoops. 1, 2, 3, 4, 5, 6. Okay. I'm going to actually move one of these over here. So this is where you might start just making your own decisions about where do I place my electrons on my Lewis dot structure, just so you guys know. Okay. All right, here's the hydrogen one. Here's the other hydrogens one. You can see where all the oxygen ones. This is the bonded structure for water, okay? Another way to write this, when you have these big circles here, you can also write this out as this. Bum, 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 bum. Okay, that would be water. There you go. Okay, now you get into some more complex situations sometimes because sometimes one bond between two elements just isn't going to cut it. So we're going to look at a different one you guys might be familiar with, which is carbon dioxide. Okay, so here's our carbon. 1, 2, 3, 4. Here's our oxygens. Remember, carbon dioxide is CO2, so we're going to have 2 oxygens. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. Now, this is where you're going to probably have to make some of those decisions as to where do I place my different atoms. I'm going to take these 2 sets and I'm going to rotate them a little bit. So if you remember earlier, I was bonding them together to the side. So I need 2 more oxygens over here, or sorry, 2 more electrons. I need 2 electrons over here. I need 4 over here. Some of this is just kind of like a guess and check a lot of times is the best way to think of it at the beginning level when you're first starting to do these. But here's what I can do. I could share these electrons, and when I do that, oxygen now has 1, 2, 3, 4, 5, 6, and then it's also sharing this 7 and 8th one. So now this oxygen's happy. Let's take a look over here. If we do the same thing, 1, 2, 3, 4, 5, 6, and then it's sharing this 7th, 8th. Now let's take a look at our carbon. Our carbon had these 4 original ones, 1, 2, 3, 4, and then it also is now sharing 1, 2, 3, 4 more. So it is sharing these electrons. Okay, again, these are part of them. Carbon has 8 now, so it's happy. So here's kind of what we would write at the end there. Carbon, this is what we call a double bond. So there's our Lewis dot structure for carbon dioxide. All right. Now, you can go up to a triple bond between 2 different atoms, okay? You cannot go to a quadruple bond. There's not going to be something that, at least that we deal with, where you do that, okay? In fact, I don't think there is such a thing as a quadruple bond. But I'm not like a genius or anything. I just act like one. So. Sharing of electrons. You have to do a little bit of guess and check on these. Drawing the Lewis dot structures. This is where the Lewis dot structures come in handy quite a bit. So if you have any questions, please email me. And you're going to do a set of practice problems. And from there, we'll be able to determine how well you're getting this. Tomorrow you'll learn a little bit more of the specifics of how covalent bonding works as far as like the model that we have for that. And then we'll go from there. So we'll catch you later.